are buried under the basement often, or
How far down do they get buried?
The deeper the better, typically, because
so they're a total pain in the butt to get at if you need to.
Yeah, I mean, you got to send a little kid down with like a toothbrush or like a bucket of bleach.
The better thing is to just don't do this. Welcome to the Fine Homebuilding Podcast, our weekly discussion of building, remodeling, and design topics aimed at anybody who cares deeply about the craft and science of working on houses. This is Senior Editor Patrick McComb. I'm joined by Design Editor Kylie Jacques.
Hello.
Deputy Editor Matt Milham.
Hi.
And Producer Carrie Delahanty. Please email your questions to fhbpodcast@taunton.com and include a mailing address so we can send you a sticker. You can find previous podcasts and check out the show notes at finehomebuilding.com/podcast. Wow, we got a lot of feedback, and it seems like so many things have happened since we last recorded the show.
Oh,
At least
like
since we last
older.
recorded it in here, but yeah, also since we came back from IBS.
Yeah, so those of you listening may have heard that we were going to the show. Those of you listening in order will be a little confused because there's a bunch of stuff that's happened between then and now.
Yeah.
But that was your first trip to the Builder Show, Kylie?
It was. I will have a better game plan for next year. I want to know where I am at all times. That's my goal.
Yeah. Well, it's going to be in a different place next year.
I know, but
so
I still have a better sense of what it entails.
Yeah.
You know?
What did you think?
It was a learning curve for me. I got a lot out of it.
What do you think about Las Vegas as a fun-loving town?
Well, that's part of it. My tolerance level is pretty low for that stuff. But yeah, I mean, there's a lot of enthusiasm around the show, which is always contagious.
And we met some fans.
We met some great people.
Stopped by the podcast booth, and we had our Keep Craft Alive event.
That was very fun.
And we met some interesting people there.
Absolutely. Very smart people.
What do you have to say about all this?
Yeah, it was great. I was kind of dreading it because going to these shows, it's like always a little bit overwhelming being in these gigantic halls with tons of people, and for us especially because we got to run around and meet with all these representatives from different manufacturers. And it's not that it's overwhelming; it's just like a lot of times they're pitching you like the same stuff you've already seen, or like tiny little iterations on that. And it's like, yeah, this isn't groundbreaking. Thanks for taking a half hour of my time and taking me away from looking at stuff that I actually wanted to see or find. But I don't know, but it was more fun this year, and I don't know why. I don't know if
probably getting more comfortable
normal
with it.
Dark attitude changed while I was down there because it was sunny.
I don't think that happened. We also learned that you have an incredible golf swing.
Yeah.
Well, I can swing hard. I can't swing straight.
How about an incredible slice?
Yeah.
Right.
I've got a really great slice. I got it out of the pen, I think, 3 or 4 times, according to you. I don't know if I actually could see it because
I had been drinking a lot.
Were you guys familiar? Were you familiar with that whole Top Golf thing?
Never.
That's a chain.
Yes.
Yeah, I didn't know that.
And apparently it's a very money-making chain.
I bet so, yeah.
So it's the perfect thing to have in Las Vegas. Yeah. So for those of you who aren't familiar, it is like a driving range on steroids. It's all electrified, like so, and there are actually RF transmitters in your balls, so you can track the flight path on a video replay, for example.
It's like playing a video game, but like
swinging
with actual clubs.
Right.
Real golf club.
It's like the next
hitting a real ball.
Yeah.
Yeah. It's amazing.
Yeah, it's a lot of fun.
It was a lot of fun.
I think that probably more than anything is what contributed to my good time.
I had a great time. Do you want to describe the woman you met, or would you like to describe the woman you met at the Keep Craft Alive event? I did too.
Yeah, we were there together. Yeah, she's lovely. Her name's Mariana Pickering, and she's the co-founder of the EMU, I assume is how we
I think
she
so.
said, EMU Systems, which offers builders passive house training based on curriculum that she and her partner have developed.
So for those of you listening, Mariana had this amazing T-shirt, and it said, good girls build...
badass girls build...
it says good girls build a code, badass girls build passive house.
Yeah, I couldn't see that part of her. Print smaller up top. Yeah, she was...
Cool.
I just loved the passion that she felt. She described herself as a recovering architect.
Yes. I think that's a good description.
Yeah. She has a master's degree in a field that I wasn't familiar with. It's design science in sustainable design. I've never heard anybody declare that before. So
we'll have to talk to her more.
Yeah,
I think there's
she travels a lot. She studied in Copenhagen. She's so essentially builders or tradespeople come out with a certification. They're a passive house.
So they go to her school in Colorado and they get certified as tradespeople in the passive house program.
Yep, it gives a little bit of weight to their credentials.
And I'm sure it helps folks understand what exactly they're trying to do with this model building standard.
Right. And they use these passive pods that they build and use as a teaching tool.
Yeah, so they look like little dog houses, but they have windows in them and like penetrations and stuff, and I'm sure she's teaching folks how to deal with that. It's cool.
I think it's pretty clever.
I'm sure you have strong opinions on this.
I have some opinions. Mostly I was thinking about the degree that she got. It sounds like the Department of Redundancy Department.
Yeah, right. Yeah.
But
well, it's always exciting to see other women in a room at an event of ours, right? So
yes.
I of course, gravitated to the educational aspect of what she's doing because that spoke to me.
I've never met anyone who trained tradespeople to have passive house credentials. So I think that was very interesting.
Yeah.
Like, I hear about this, but I'd never met one.
Yeah.
It's cool.
Their tagline is "Run wild, build passive."
The thing is, I'm all for like building better houses, and I'm all for verifying that the things that you're doing are working, and that what you've done is you're achieving what you set out to do. But some of these programs, like where you have to pay just gobs of money to get certified,
to get a plaque.
Yeah,
It's
just
I don't get the feeling like that's what.
No, she wants to build better houses.
Is.
Yeah, she wants to build better houses.
Yeah,
like,
and that I'm fine with.
Right, I hear you. I think it's really
I have no
grassroots,
trouble with people
scale.
displaying their plaque. I mean, people drive BMWs and Maseratis and Ferraris.
And
like
they put our podcast sticker on their car.
On their Ferrari? I've never seen that.
Yeah.
If anyone's got that photo, I'll take it.
Anyway.
So after the show, I spent a little bit of time touring around with the family. They flew out after the show. But before that, I had a whirlwind weekend. So we were supposed to fly to the show on that Monday. And on Saturday, I'm like frantically doing laundry to get ready so I, look my best. And
get all of your plain T-shirts.
And T-shirts and jeans and what. So I'm like, get the clothes out of the washer, put in the dryer, turn them on, and like 20 minutes later, the thing shuts off, and I open it up, and they're soaking wet, like nothing had happened. And I'm like, this is a problem.
Mm-hmm.
So what did I do? I tried again. I set it again. I was like, well, that was a glitch.
That's fair.
Yeah, didn't work. Nothing worked. The vent wasn't plugged up or whatever, so I realized that my heating element had failed in the dryer.
Oh, no.
And so the problem with my laundry equipment is that it's in this tiny closet in the kitchen, and you literally cannot fit in there to make the connections. So you have to make the connections and then push the thing in the hole, right? Mm-hmm. So it's a big job to get it out. But the bigger job was getting the dryer apart sufficiently to access the heating element. Mm-hmm. But thanks to the modern times we live in, I was able to see this whole process on YouTube. And I think I sent you a photograph of my dryer, which I have up here. And
I was amazed at how clean it was, but you told me you vacuumed it out.
So it was full of lint and coins. Apparently, pennies and dimes will fit through the tiny space between the drum's rotation and the housing.
Oh, that's a problem.
Huh. Yeah.
Seems like a problem.
I came up with like 18 cents.
At least you discovered it sooner than later. I had that same issue going on, and it took me. I would just
keep running it.
How
long does it take to dry a load of clothes?
Hours. So stupid. And then there was a little fire. I wound up having a fire.
How exciting!
Electrical, like poof. Yeah.
Huh.
But it smelled really bad for a while before that fire. So dumb. I learned some things.
So. I was really thinking about buying new laundry equipment, right? Because I'm always thinking about that. But and so then I was like, well, that's $600 to buy a new dryer, and it's not going to fit on my stacked washer, right? I'm going to have to buy a pair,
right?
So I'm like, well, that's $1,200. No. So I looked into what it would cost to get it repaired, and that was a $300 repair. But I bought the parts from Amazon for $30.
Wow!
And did it yourself?
And did it myself, and then you know what? It worked.
Cool.
That's awesome.
That's the best part.
Yeah.
And the stuff came on Sunday, and I was able to do my laundry before we went to the show.
Nice.
It was really a victory.
That sounds a little bit stressful.
It was terrible, Kylie. And I don't know if... do we have the picture up there, Carrie? Are you sure?
I thought it was in there. But anyway, you don't have a laundromat in your town?
Yeah, we do.
Oh, okay.
Have you ever hung out at the laundromat?
There are some good ones and there are some bad ones.
So the other Yeah, so I decided to fix it, so I did. And I would tell anyone who has an appliance problem to go to YouTube and try and buy the parts online and do it yourself, because it is not. I've done this a few times now, a few different appliances, and it's generally not hard. There's usually like these websites that cater to selling the parts often have tutorial videos and a flow chart to help you figure out what the diagnosis is, so you're not chasing your tail.
It's not like diagnosing a horse where everything is just like shoot it.
So random.
I mean, if I were an appliance manufacturer, that's what I'd do. Sell more appliances.
So this thing could have been, don't get me started, but this thing could have been designed to make it so much easier to make this repair. All it would have taken was an access panel on the bottom of the machine so you could turn it on its side, take out a few screws and get to the parts. But no, you have to take off the top. You have to take off the front. You have to take off the control panel.
Right.
You have to pull out the drum. You have to take the burner or the heater assembly out of the unit. It's
Sounds like $300 worth of work.
It was.
Yeah.
That's the thing. They're probably trying to encourage you to hire their maintenance
Or buy a
crews
new
or
one.
whatever,
Yeah.
or buy a new
Yeah.
one. Yeah. It's just
You know,
like
that's
cars.
the sticking point with those stacked units. One goes, and then you have to replace both.
Yeah, unless you can find something that works with the
typically,
I don't think that's
It's not
going to be
easy.
likely.
Yeah.
So the other thing I did is after the builder show, the family came out and we went to the Grand Canyon. And on the way there, we stopped at the Hoover Dam. And I learned this morning that you've been there.
Yeah, I've been there a couple times at least.
And the reason I bring this up is because this is an amazing place. To the point that it was the biggest construction project undertaken in the entire world. I don't know if you want to count the pyramids of Giza being a bigger project, but in modern times, you know, this was as big a deal as anyone had ever conceived of. It took 6 construction companies working together to get this project done. And forgive my patriotic ramblings here, but as an American, it's like we got together and decided this was an important thing to do. We need to put people to work. We need to control flooding in California and provide for irrigation to grow crops in the Imperial Valley. And we did this 2 years ahead of schedule.
I didn't know that.
Yeah. And what's more remarkable to me is that if you go down inside this thing and if you take the tour run by the Bureau of Reclamation, they let you go down inside and look at the generating facility and see the inside of the dam itself, and it is beautiful. Like there are these gorgeous terrazzo floors, there are the Art Deco details, and none of that was necessary in this very utilitarian structure.
Did they explain why they did that?
I don't know.
Yeah.
I think it was to put people to work. And the terrazzo floors were done by the same company, and they're gorgeous. This little thing here is an electrical receptacle from the 30s, and they were.
Wild.
Isn't that cool?
Yeah, very cool.
So someone designed that, and they actually put it in the floor without value engineering it, and it makes the space so much nicer.
Yeah.
And I think that's undervalued in our
Absolutely.
in our
Amen.
built environment, right?
Yep.
That beautiful things make you feel good.
Yes. Well said, Patrick.
I have more to talk about too, but I'm not going to waste any more of our time. But we also went to the Grand Canyon, and there are these fantastic buildings there designed by a woman by the name of Mary Coulter, I want to say. Mary Jane Coulter, 1869 to 1958. She designed these buildings for the Fred Harvey Company and the Santa Fe Railroad. Many of them are in the Grand Canyon National Park. And I would call them architectural follies that draw upon the vernacular architecture of the Pueblo people who inhabited the area for thousands of years. And they're these stone buildings and just amazing. So I'm going to put some
You sure know how to have fun.
I love stuff.
Yeah.
You know, I love seeing new stuff.
listening to you describe stuff. You have a nice way of doing that.
I'll put some of these photographs up on the podcast page, and I would encourage anyone who's traveling the Arizona/Las Vegas area to go check out the Grand Canyon. The canyon itself is amazing, but the architecture that was put there later is equally cool. What do you got to say?
I got nothing.
You've been working on your house? There hasn't been time, right?
No.
We've been traveling.
Yep.
Yeah, I got some cabinet-grade plywood yesterday. Coming back from a photo shoot, I passed a place that had it, so I bought it. And I'm going to start making some more cabinets for my bedroom. So
Cool. Where was that? Where'd you find that?
Gaylordsville, Conway Hardwoods.
Oh, okay. Yeah.
So those of you in the area, if you're looking for a large selection of cabinet plywood, that's where to go. And I was able to find pre-finished cabinet plywood, which I have not been able to find anywhere else.
How much more do you pay for that?
A lot.
Yeah.
I want to say the sheets were $110 versus $80.
How many sheets did you need?
Just 2.
Oh, okay.
Honestly, the material costs in my cabinet projects are minimal compared to the labor
Right.
drain.
Will that be the last project that you do in there?
So for me, maybe. Carol's charged with making some window coverings right now. She bought a new Japanese sewing machine, and I think that's going to be her first big project.
That sounds interesting.
Cool.
Yeah. Sewing machines, very cool.
Beautiful machines, yeah.
The engineering, just
They're
the
as good
things
as
they do,
typewriters.
just,
It's
I still
amazing.
can't wrap my head around it.
It's amazing.
Like, how does it thread through that? I don't get it.
I don't understand either.
Yeah.
And like this wasn't a super expensive machine. It was several $100s, but like it is mind-boggling the things it can do.
I know. I had a 1924 Royal typewriter restored recently, and I spent some time with the guy who did it to get a feel for all of the mechanisms on this machine. I can appreciate the aesthetics of it, but they're all functioning. They all do something, and
Isn't that
it was
cool?
really wild. I
remember
really
as
enjoyed it.
a little kid popping the top on the old typewriters we had in the house and just being fascinated by the machinery
The
inside.
machinery is just beautiful.
We don't see typewriters except in Kylie's house ever anymore.
This one works like a charm too.
So, do you guys remember that? I don't know if you were on, Kylie. I think it was definitely Rob and Matt. Rob was on, and I think you were on with Rob and I.
Okay.
He was talking about how it took more energy to heat humid, or what? How did he describe it?
Oh, yeah. I do remember that
Air with
conversation.
a higher concentration of water vapor in it takes more energy to heat than air with a lower concentration of water vapor.
Yeah,
That
and I don't remember how that
seems
came
to
up,
make
but I
sense
remember
to
that
me.
conversation.
It makes sense to me, too.
Denser air.
So we heard from someone who knows way more about this than Rob or any of us. Go figure. Kevin wrote in, my day job as an HVAC engineer, I only work on commercial buildings, but the science is the same. Humidification is not costly because it is harder to heat the air. It's costly because it takes time or energy to evaporate the water. It's a difficult concept to grasp, but I like to think of it in terms of wet bulb temperature. I'm sure you've heard the term wet bulb and knew that it was related to the humidity of the air and that is lower than the regular dry bulb temperature. The wet bulb temperature is defined as the temperature the air would decrease if it were passed over water. For example, air at 70 degrees dry bulb temperature and 40% relative humidity has a wet bulb temperature of 55 degrees. So if you pass 70 degrees, 40% relative humidity air over water, the temperature of that air would decrease to 55 degrees. This is what your home humidifier is doing. It's adding humidity to your air at the cost of lowering the air temperature. This causes your furnace to work harder. How much harder? It depends on how much water you need to evaporate and the latent heat of vaporization of water. In other words, how much energy does it take to evaporate a pound of water, which is about 0.1 therms of energy per pound of water.
But we're talking about water that's already evaporated in the air.
That's what
That is what I don't get in this description.
I know, and I was going to...
We're not evaporating water in this situation. We're talking about evaporated water that's already in the air.
Right. I think it makes perfect sense that in order to evaporate water from liquid form, you need energy, right? It's like what you're doing is doing a phase change, which takes energy.
Right.
Okay, so he has, let's take an example of a really good 2,500 square foot house with 8-foot ceilings. So 20,000 cubic feet and 3 air changes per hour in a really bad climate on the worst hour of the year. 0-degree dry bulb and no humidity with enough wind to cause the temperature differential for 3 air changes, which would be about 20 miles per hour. During this terrible hour, you'll pull in 60,000 cubic feet of outdoor air. In order to heat that air up to 70 degrees, your furnace will have to put out 0.75 therms in order to bring that air up to 40% relative humidity. So what he's saying is like, in order to humidify the air to your desired amount, it's gonna take more energy on this very cold day with wind than it would on a warm day with less wind.
But he's talking about adding that humidity to dry air.
Yes.
Yeah, so he's talking about... we weren't talking about humidifying the air. We were talking about heating humidified air.
Well, so this is a very good aspect of this discussion is I really don't remember what we were talking about. So in other words, I think that his point is good. Is if you want to humidify your air, you're going to have to vaporize that water. So it's going to take energy that's impossible to do without an energy input of some sort.
Yeah.
And that might have been what Rob was talking about, but I have no idea.
I was probably zoned out when he was talking about
Well,
it.
sometimes it's easy to zone out when Rob is talking.
It does tend to go on.
It's a good thing he doesn't listen to this podcast.
So he
So
goes
it takes
on.
energy to humidify your air and dehumidify
So
your air.
we've
right?
established
Yeah.
it takes energy to humidify the air, but now he's going to go into like it's not very much. So on the worst hour of the year, humidification can be about 25% of the cost of the air leakage. Where I'm at, one therm of natural gas costs about $1.25. So we're not breaking the bank if we have a tight house, but it is a significant portion of your HVAC costs. If you're planning on humidifying your home, air sealing is even more important. That makes sense to me either, because if you have air changes, you're going to need to increase the humidification rate too, right? Because that humidified air is going out with the heat.
Well, also it's going through the building assembly and can condense on any condensing surface.
Which
So-
is always the thing we
yeah.
remind people. If you have to be very careful if you're humidifying your air, that you run the risk of having moisture problems
assembly,
somewhere
right.
from
Yeah.
air leaks.
Actually, yeah, I'm working on a story right now where they had to maintain 30% relative humidity inside the house, and the wall assembly became really important. They wound up putting the vapor barrier inboard to keep the thermal, to keep the sheathing warm enough so that it wasn't hitting a cold condensing surface.
Yeah, you don't want that cold air to get to the sheathing, or it's going to get moldy and rot. He says, energy cost is just one consideration to take into account when deciding whether to humidify or not. Condensation, that's what we were just talking about, drying potential, thermal comfort, and health all need to be taken into account. But I think I've been as dense as I can for one email. Thank you, Kevin. It's always we always appreciate hearing from someone who knows what they're talking about. We also heard from Ethan, who has a Sanden heat pump water heater. He writes, I'm an architect in Cold Spring, New York. After a long process, so we asked folks who had installed these for feedback on what it's like. So for those of you listening who don't know what it is, it's like a split air conditioning system, except instead of making air that you're going to distribute through your house, it makes domestic hot water. So the compressor and the condenser... No, the compressor and the evaporator are on the outside, and the condenser is on the inside heating the water. I think I got that right.
Something like that.
One of the things is on the inside, and one is on the outside.
Yeah, it's like a
So
mini
it's a
split
heat
for
pump,
hot
so I
water.
think it's the condenser's on the inside and the evaporator's on the outside, which is the opposite of what you have with an air conditioner.
Are these fairly common
No.
to use? Okay.
Because they're expensive.
Okay.
This thing's like $4,000.
And what's the advantage?
Well, I'll
Okay.
read what Ethan has to say here. After a long process of perfecting wall, roof, and ceiling assemblies, it became clear that providing domestic hot water efficiently was the next most important thing to do in our high-performance home. I ran various calculations regarding recirculating showers, like the orbital system. Have you heard of this?
No.
I had to look this up. So this is a Swedish thing, and it's a shower that reuses the drain water.
Gross.
That sounds disgusting, right?
Where does it reuse it?
Yeah.
It sprays it on you.
Oh, what?
Yes,
Like a dishwasher?
exactly.
I'm not a dish. I don't want that
That's
dirty
so
water coming
strange.
back at
That's
me.
what I'm thinking. I'm like, you're really disgusting, and you have coal soot on your body, and then you're going to spray it back on you.
And what if you pee in the shower?
You don't do that, do you?
No.
Let's not get into that, fellows.
So he says, orbital system, they call it the Tesla of showers. But my family takes a lot of baths, hot water heat recovery, which is a method of like wrapping a drain pipe with a copper coil, so you're preheating the incoming water. Have you seen these
Yeah.
things?
Rob,
Have you seen these?
Yeah, Rob and I had a discussion about these.
So that's a pretty cost-effective way to lower your domestic hot water heating energy bills, but it doesn't work with baths because you don't have this flow of warm water to transfer that energy into the incoming cold water, right?
Why not?
Yeah, I don't
Just wrap it
understand
around the drain.
what's the difference.
Yeah, because what's the
running-
difference?
what's running
Because with a shower, you have this constant flow of water going down the drain. With a bath, you don't.
I see what you're saying.
So,
Right.
like,
yeah.
you've filled the tub with
And that's
all
it.
your hot water,
Yeah.
but then there's no replacement with,
Right.
and there's no way to reheat the replacement water.
Yeah.
Okay.
Boy, this is deep stuff today. I don't know if we're
My head is already
get...
spinning. Got a long way to go.
Concerns regarding the global warming potential of the majority of heat pump water heaters in the market, as well as concern regarding the problems that all-in-one heat pump water heaters exhibit, winter cooling and dehumidification, as well as noise, in this very tight home drew me to the split Sanden. So it doesn't dehumidify your house, and the noise is outside. So those are two big things. Yeah. And as I understand it makes a ton of hot water, which would also be a plus. Also, I believe your analysis of CO2 as a refrigerant is incorrect. My understanding is that CO2 is a very effective heating refrigerant, but not so much as a cooling refrigerant, hence it's absent from AC equipment. So I can speak to this. I was the one who said that CO2 was not an effective refrigerant. And I think you have to look at refrigerants in a number of ways. If HVAC techs or plumbers need to buy all new equipment to service this stuff and install it, I don't know that that's a good refrigerant. The ideal refrigerant would be stuff that you can use with your existing technology and pressures, right? And the other thing about this CO2 system, they're very high pressure, so it takes some special knowledge to work on this. So, I mean, yeah, it's fine refrigerant, but it takes some adaptation. Mm-hmm. I purchased the 119-gallon Sanden from 475 Building Supply for about $4,000. The install was done by our plumber with an electric tie-in by the electrician. There was definitely more coordination required due to the split nature of the system and some extra plumbing, but I don't think it was out of the ordinary. Regarding cost, I mitigated this by installing one 119-gallon heat pump water heater for this 2-unit building. I do share some of your concerns regarding service, etc., but basically decided that in this instance, I should be the change I wanted to be, as someone once said. Basically, so I could write letters like this one. That's awesome. Regarding overall performance so far, hot water production has been sufficient, even through some major cold snaps this fall and winter. I installed a sense meter with the hope of measuring my electric usage to make water, but that was wishful thinking, and that it has not yet identified the Sanden and maybe never will. So Rob was complaining about that too, that this system could not identify as mini splits. And I am told it's because the mini splits and this heat pump water heater have these refrigeration cycles that are extremely variable depending on what it's doing. And the computer technology is not savvy enough to figure out what it is because it looks different electronically. Does that make sense?
Sure.
Thanks. Well, thank you for that, Ethan. Was that Ethan? Sure. Yes. Someone else wrote in about HFC refrigerants. I agree that there's concern about the use of HFC refrigerants because of the very high global warming potential. However, I don't agree that that's a reason to avoid heat pumps and go with a plain resistance water heater. The Kigali Amendment, which has come into force, and the whole world minus the U.S. is shifting to low GWP refrigerants such as HFO 1234YF, already in use in many cars, pentane, already used in many refrigerators, and CO2. The reason that CO2 isn't in common use is not because it's not a good refrigerant. In fact, most natural refrigerants have much better thermal properties than the CFC and HFC legacy refrigerants. CO2 must be used at extremely high pressures, and that has required the development of very specialized compressors to handle the greater than 73 bar for the supercritical CO2 cycle. Both California and Washington are independently phasing out HFC refrigerants, which could raise the price of the final products by a whole 1% because the refrigerant themselves are a very tiny fraction of the system cost. I anticipate that the cost of heat pump components will come down as people start buying more of these systems.
Stands to reason.
Yeah, that's typically how it works, except with gold.
That's just weird, right? Why do people do that? And like, what are you exactly going to do with it if the world economy or the society collapses?
Yeah,
you're going to like carry around bars of gold.
Yeah, somebody's just going to shoot you with the gun they bought for $500.
They're going to take your gold. Yeah. But I don't know what they're going to do with it, right?
Invested in guns.
Saddled with gold.
I'm going to make some bad jewelry, man.
Yeah.
All right, finally, from Bert, we got to get some questions going, huh?
Yeah.
Bert, hey there, team. I heard discussion of Gutex insulation on a couple recent episodes. And so you were raising the concern is like cutting down our forest to make wood fiber insulation actually good for the sequestration of... did I say that?
Yeah, sequestration of
carbon. Of carbon. And someone wrote in to tell us. their thoughts.
We got a lot of feedback on this. We got feedback from, or at least I got direct emails from
Ben Bogey,
Andy Engel, Ben Bogey. Yeah, and then I talked with Ben about it a bit at the show. So
tell me, like, before we read this, what the general nature of the discussion you've been having with these folks.
Okay, well, there were a couple points I think that I brought up. One, that old trees sequester carbon more quickly than young trees, which remains true. We'll get into this discussion a little bit in what Bert has to say.
Yep.
But also that, like, historically, upland forests, like not forests that aren't in wetlands, have typically been considered methane sinks, while like wetland forests basically can produce methane. And that is sort of an old way of thinking, and it's sort of recent research shows that that's not necessarily true, like that either can be a sink or a source, because there's so many variables in the soils themselves, and just there's just a lot more going on than people thought.
So Bert writes, you guys raised the perfectly reasonable question of whether the product's eco-bona fide should be trusted, given the idea that trees have to get cut down to produce it, and deforestation is a major driver of climate change. While I usually listen to your show in an attempt to soak up knowledge in a field I know little about, this point brings me into an area where I actually do have some expertise to offer. Years ago, before pursuing my PhD, I was an undergraduate research assistant in a crop and forest physiology lab at the University of Illinois. One of the things I learned there was that the decline in the net amount of carbon stored by a forest per year over time. Young forests store carbon much more rapidly than old growth, and tree plantations that are managed to remain productive can absolutely be net sinks for soil carbon. On top of that, the carbon embedded with resin and used as insulation on houses is locked away and out of the atmosphere for a very long time. Now, all of this is ignoring the fact that Gutex is almost certainly made not from good lumber, but from sawdust, fiber, and other waste products that are traditionally burned to power the sawmill or landfilled. But that's not an area I know much about. So I guess his point is that we're not even really cutting down forests to make this. We're using stuff that would be waste.
Yes.
That we know
and I don't think you can make that assumption.
Yeah.
Ideally, yes.
Well,
I think
that's wood fiber. It's a wood fiber.
So
right?
it could come from anywhere, right?
My impression is
it could
that
be coming from full trees. It could be coming from
you just need the
though?
fiber.
Sawdust. Yeah, it's just whatever.
I thought it really was just sawdust and chips and whatnot.
Well, that's what it is when it's made. Yeah,
yeah.
But I mean, you
What
can
does it start out
run
being?
a tree through a shredder.
And they do to make like wood pellets and these things called bio bricks, which are solid fuel things. You know, like oftentimes they're just scrubby trees that they ground up and press into this stuff.
Yeah.
I don't like knowing that.
But to the point of like
know.
young forests sequestering more carbon than old forests, that is true. And the reason that's true is because of the density of the trees in these young forests. So like basically you could have 50, 100 trees in the same space that you have one gigantic tree. So you're not comparing apples to oranges. Yes, 50 trees will store more carbon than one big tree, 50 small trees. But over the long still at the same time, an old forest is going to actually have more carbon in it than a young forest because each of those individual trees is so much more massive.
Those are two things. Those are two different things.
Yeah.
Right, they're two different things. So I just wanted to say that.
Don't you think the management of the forest too has a lot to do with how much carbon is being sequestered?
Yeah, and there's other things involved too. So when you cut down a tree, like roughly 45% of that tree gets left behind in the forest. You've got the roots, you've got the branches, because they're not taking trees out of the forest.
They're
taking
logs. Right.
So all that stuff gets left behind. All of that carbon that's stored in those branches and those roots and everything ends up going back into the atmosphere in one form or another, either as carbon dioxide or through chemical reactions, methane, possibly, depending on the conditions that are there.
That's one thing I learned, that
there.
you need wet soil for methane production, which is one of the... Go ahead.
And the thing is, yes, true. You need an aerobic environment of some sort.
Right?
Anaerobic environment of some sort. So that can exist even inside of a tree. There have been studies recently where, people just for sort of like, I don't know, poops and giggles, drill holes into trees and like put a pipe in there and light it on fire because of the methane that's coming out of the living trunk of the tree, because there's that environment and those
There's
bacteria.
water in there, and something is.
Either it's taking it up from the soil or it's being produced right in the trunk itself.
Crazy.
Yeah.
I love this stuff.
So we have a really smart audience, and I thank all of you for listening to the show who write in with your expertise. It probably makes the show, it makes the show way more valuable than it would be with it just us.
And it gives me more stuff to read.
Yeah.
Yeah.
Wow, we got to get to some questions here. This one I think is pretty easy, so we'll tackle this first. Hey, FHB Podcast. I am a huge fan of the podcast, and I look forward to the creative ways that you convince people to air seal their homes. As an energy auditor by profession, I appreciate all that you do to make my job easier. I live and have been working in New England for a number of years, but I have a question about my parents' retirement home in upstate New York. On my first summer visit, I immediately felt the high humidity levels in the basement and noticed a faint moldy smell. The ductwork for the basement furnace was buried in the slab. I have never come across this in New England and could not imagine why anyone would ever attempt such a thing. Is this a poor man's radiant floor heating? Fast forward to when I was over there during the holidays. The humidity was still very high, even with below freezing temperatures outside. They need to constantly run a basement dehumidifier and dump 2 50-pint buckets a day. So that's 100 pints of water a day. I know you guys needed help with the math. I had them place hygrometers in each room which consistently read 70 degrees. My hunch is that the warm, dry air going through the concrete is expediting capillary action through the slab, most likely in the front of the house where the slab is 8 feet below grade and well below the frost line. The ductwork was just scoped by an HVAC contractor, so that means he put a little camera down there. And the news was not good. Crumbling concrete, rusted sheet metal, etc. My questions are as follows. Is there a way to salvage the ductwork? Perhaps a pressurized liquid-applied membrane similar to AeroSeal? Why did a builder at any point think this was a good idea? Is there something I'm missing? I'm concerned for the home's performance, but especially the indoor air quality as my parents get older. I feel like the safest solution is to fill the ductwork in with concrete and install mini splits. So how long do we want this question to take?
Yeah, I don't know. I'm curious when this house was built because, I mean, this sounds a lot like earth tubes, which were kind of like a big thing in the 70s. And actually, I was at something. I don't know.
Yeah, but so earth tubes, though, are not...
They're for
You're
cooling.
not using conditioned air.
No, you're using basically the
soil
temperature of the soil.
What are they made out of?
And all kinds of stuff. I mean, people use just
PVC
like culverts.
pipe, galvanized pipe.
Yeah.
It's a very bad idea if you're considering it.
Yeah, I think you probably get some angry letters on that. But yeah, I was at
angry letters saying that I'm wrong?
Well, people who are really into earth tubes and that kind of thing, yeah.
Yeah, they're really wrong.
I'm
just going to say
saying
that.
they're right. I'm just saying they're a rabid bunch. But yeah,
they are.
Yeah, I was in
They're rabid, all right.
I was in a talk at a library in the Adirondacks because this guy's like, it sounds like somewhere in upstate New York. And some lady approached me and we were talking. I guess she knew my mom, and so she knew that I worked here.
Yep.
And she was trying to sell me on earth tubes.
What did she say?
So it's like a thing up there. I don't know, just like, oh, it's like revolutionary. I'm like, yeah, I know a little bit about it.
Revolutionary from the 70s?
I know. It's the thing that's been around for a long time.
So the thing that inevitably happens, right, is these things fill up with water, and they're in the soil. So what ends up happening is they're like filling your house with mold particles, right, or spores, and smells. They stink.
Well, that's the thing. Like, you're moving air basically through them. Like, you know, they are nice and cool down there in the basement or wherever they are, buried under the basement often. Or
how far down do they get buried?
The deeper the better, typically, because...
So they're a total pain in the butt to get at if you need to.
Yeah. I mean, you got to send a little kid down with like a toothbrush or like a bucket of bleach.
The better thing is to just don't do this.
Don't do it.
Yeah,
right.
but you're forcing air through it, and so all that humidity ends up, you know, condensing on this cool surface inside there. It fills up with water, gets moldy, it's gross.
So the real thing going on here is that was a thing people tried for a while, is to put ductwork under the slab. And there's a bunch of homes in the Chicago area, and Bill Rose weighs in on a Q&A spotlight written by Scott Gibson for Green Building Advisor. And this is the most intelligent discussion of this whole problem I have seen. I don't know that there's any more other information about this, but this is a terrible idea because inevitably the ducts rot out and they're letting large amounts of moisture into the heating system and into the basement. And of course they get full of mold and stuff because they're like, how are you going to clean this?
Well, yeah, and you're putting this in a basement. Chances are when this was built, like there's probably no radon mitigation. Ductwork is extremely leaky. Radon's getting in there. You're intentionally blowing it through the house.
And that's another point that these folks make in this Q&A spotlight on GBA, and we'll put that up on the podcast page. And I think your instinct to abandon them, fill them with concrete, and put mini splits in is the only solution. Some other heating system, right?
Yeah, I mean, you can go with some sort of, if you want, like radiant floors still, like just do a hydronic system. There's a bunch out there that can be used in new or retrofit situations.
Or you can run ductwork in the basement. This house has a basement, like run a trunk line like is conventionally done and just run away from this.
I hate forced air. That's the only reason I would go with something else. But a mini split would be great.
Yeah, he's probably going to take more than one, but...
Yeah.
He's right to be concerned about indoor air quality, it sounds like.
So I just want to read what Bill Rose, who is our building science luminary, this company, National Homes, many national homes from the late 40s and 50s were built with ducts embedded in slabs. Water entry into the ducts was and is unfortunately common, so many such subslab systems have been abandoned. Add fire and radon to the concerns raised with these problems, or with these ducts, so...
I mean, the water problem, I don't think that has anything to do with the duct. I think it just has a wet basement.
Yeah.
It's not contributing to that at all.
I don't think so, no.
Well, I believe that, so these ducts are in contact with the soil, which is going to be pumping tons of water because you're passing dry air through them constantly. It's going to be picking up that soil moisture and blowing it into the house.
I don't doubt that it's doing that, but I think I think that there's a wet basement problem to begin with.
Seems like
that water is like that's.
I don't think
it may be moving the water, but it's not the source of the water.
The problem is diffusion through the slab as much as it is the ducts distributing the water vapor into the basement space.
Is it a huge project to fill in ductwork with concrete?
Boy, I've done a lot of construction projects in my lifetime, and that is not one of them. I imagine
seems like
it'd be a pain.
Yeah.
Yeah, you probably have to cut it open, expose it, and then just pour it in because you're not going to be able to pump it in and with like any sort of
reliability.
That you're actually getting it where it needs to go.
I thought of foaming just the outlets with spray foam. Like, why wouldn't that work? You don't have to fill it. I mean, just like stop the air movement.
Yeah, unless he's getting a lot of cracking and he's worried about structural integrity of the thing. I don't know.
I would say as a first step, just plug up all those registers with spray foam or cut and cobbled and get a new heating system.
Yeah.
Hello, Fine Home Building Pod. Longtime listener, love the pod and listen to it while I stand at work. I'm a cabinet maker in a commercial millwork shop. This spring, I'm adding an in-law suite and 2-car garage/wood shop onto my house. I'm acting as the GC and summing out what I think makes sense to speed along the build. My role will be to outfit the interior from drywall and cabinetry to trim, etc. My question has to do with an existing rotting carport that I need to remove from the house. As far as I can tell, this carport is attached with a ledger board nestled underneath the flat roof on the mudroom. I think the carport is only attached with nails through the ledger. My plan to take it down is to attach some temporary support beams in the middle and ends and using a sawzall, cut through the rafters and push it over, after which I can rip the ledger board off and move on with the addition. Do you see any issues with doing it this way? Is there an easier, better way to take this eyesore down? I've included photos of the house and the drawings of the addition. I plan to make the flat mudroom roof pitched. And when we start the addition so that the rain and snow will fall off and not get trapped up there anymore. Thanks so much for all you do. As a first-time homeowner since last December, I've had to learn a crazy amount. I find that I absorb good information through you guys. I like the variety of questions you answer. I end up having heard something about a problem I encounter in the house. It was built in 1912, so problems I got, and I feel empowered knowing I can find the information I need. Well, there you have it. So how to take down the carport. You're looking at me.
Yeah, well, I wasn't sure what he meant exactly by the putting beams or whatever in the middle and ends.
I think he's overthinking this.
I don't know. I think you can just go up there, get a demo blade for your circ saw, go up.
Cut the roof, sheathing.
Set it at like an inch, cut through the sheathing and the shingles in, I don't know, 4x whatever size sections you feel like you can pry up, get that off, and then just cut the rafters loose one by one. And my main concern is that if he tries to take it down in one swoop,
sounds
the
dangerous.
weight of that roof, like unless you have that calculated, is going to want to bring that whole assembly into those posts that I assume that he wants to keep. And you might end up knocking down that part of the roof too while you're at it.
So I would say the general rule with demolition is like do stuff in the reverse order it was built, right? So the last thing that was done on this building was the roofing material was put on the sheathing, right? Mm-hmm. So if you get the roof sheathing and the roofing material off, and then you'll have just much lighter assembly, right, to deal with. You cut the rafters one at a time or whatever. Truth is, though, I would be very tempted to cut up the posts or wall that are supporting this and pull it over with a truck.
Yeah, if he's got enough space and enough confidence that he's not going to knock down or
damage
hit stuff
something
that he wants to keep.
Seems like a good idea to get some weight off of it before you start dropping it, right?
Yeah.
Seems
you guys are such wimps, I tell you.
I'd much rather
he
get
doesn't
hit
want
with
to
a
damage
Nerf
the side of his
bat
house.
than a wooden bat.
What'd you say?
Much rather get hit with a Nerf bat than a wooden bat.
That's fair.
Yeah, so the safe way is to pull up the roofing. I find a great way to get up sheathing in this kind of assembly is if you get a sledgehammer from a ladder or the slab level, if you can reach it, and you beat on the bottom side of that roof sheathing, it'll sometimes break it loose and pop it up. Mm-hmm. Then if you have someone on the top, you can use a flat shovel works great to get under the pieces of plywood and pop them off.
Yeah.
Or you could just yank it down with a truck. Make sure you videotape if you do that.
Yes,
right?
Please do.
I don't think you should be encouraging that, Patrick.
You don't?
There's not enough fail videos on YouTube.
Let's go to Jourdan. Hey, FHB air sealing, insulating, and answerers to all weird building science phenomena. Well, that's quite a salutation. My name is Jourdan. My wife and I own a 2,400 square foot farmhouse that was built in 1780 in upstate New York, about 10 minutes north of Saratoga Springs.
Almost every question today is from New York.
I did that because you were on the show. We purchased the home with the intent to renovate and flip while we lived there. We purchased it in September of 2018, and my son was born November of that year. Well, that's good timing. We have started demo on the upstairs portion of the house and have plastic on the doorways of the stairwells to avoid dust and debris going into the living space. Well, that's a very good concern because you have a little tiny child crawling around who is very susceptible to lead poisoning. Their little brains are just getting going. I own my own small-time renovation company and grew up with a father that's a contractor. With all my years around and working in the trades, I haven't run into some of the questions I have with this home. This question involves insulating and air sealing. My wall assembly is cedar lap siding right on the framing, which I can see daylight through in some spots now that we had the lath and plaster removed. Would you guys suggest spray foam in the stud bays right onto the backside of the siding, open or close cell, or just caulk the siding and fiberglass and use fiberglass? I'm also trying to be cost conscious since we're redoing the entire interior of the house at the same time. Same question applies to the ceiling of the upstairs. The roof assembly is metal roofing, OSB sheathing, and old barnboard style sheathing that runs horizontal on top of the rafters. The rafters are true 3x4 beams that are spaced 3 feet apart. Although it would lower my ceiling height, I believe I will be adding in dimensional lumber 16 inches on center. 1 for more support and 2 for a larger stud cavity for added insulation in our cold climate. I vaguely remember you guys talking about collar ties in one of the podcasts. Is the rule of thumb that collar ties can go no higher than a third of the length of the rafter? I would like to raise the collar ties, but don't want to compromise the strength by doing so. I'm sure I'll have more questions for you guys along the way, since this is the oldest home I've ever worked on. I can't wait to breathe new life into it and pass it on to a family that will enjoy it for years to come. I also want to let you guys know that I've only subscribed to the magazine for about 8 months now and wish I had done it sooner. I found the podcast shortly after subscribing, and you guys are a wealth of knowledge. I appreciate you sharing your knowledge and know-how with me and others like myself so we can understand the building science behind the materials we work with on a day-to-day basis. Well, thanks, Jourdan. That's nice.
What do you want to start with?
Oh, my God.
Claps?
So let's start with the collar ties, and then we'll get into the wall assembly.
Okay.
So I think you can answer that.
Yeah, top 1/3 is where they need to be. Because the collar ties, I assume he's talking about not rafter ties, but collar ties near the top.
I guess.
Yeah. So their job is to prevent the rafters from spreading away from either each other or the ridge.
But wouldn't they be more effective lower down?
No, because they're preventing the thing from going out like that.
Okay. And if they were lower, what would happen? The rafters could potentially
still-
push off
They
the
can more
ridge?
easily pull away. Yeah.
Okay.
So it needs to be in the top third. It's probably really, I mean, they're resisting more force closer they are to the top. So as far as I know, they're not supposed to be any farther down than 1/3 from
That's what I read.
the peak.
Not that I know,
Yeah.
but that's what I read.
If you're talking about rafter ties, that's something different.
So we should clarify, because I'm not sure what the difference is.
Yeah. So one is preventing spread at the walls. That's what the rafter ties are doing. You're basically resting on the wall plate, and
it would be a ceiling joist in many instances, right?
And often that's what the ceiling joists are, and they're preventing the roof, like a cut roof, from spreading at the walls. But
because the rafters are pressing against them as they're loaded, right? They are pushing out against the walls where they bear.
Right. While the collar ties are preventing the rafters from separating either from each other. In an old house like this, there probably isn't even a ridge beam. The rafters may just kind of actually be lapped at the top.
Or they butt into each other.
And so the collar ties are preventing those from coming apart up there.
Dig it. Okay.
Yeah.
So a top third of this span if they're collar ties.
Mm-hmm.
Okay. That's easier. So then the other thing is he needs to insulate this assembly with the clapboards right on the framing. And we've answered this question before, but I think the solution is to put 30-pound felt in the stud cavities, staple it up onto the sides of the studs, and then spray foam against that. You don't want to spray exactly on the back of the clapboards.
Definitely not.
Yeah.
I mean, the reason they've lasted, I assume these are old claps, and the reason they've lasted this long is because they've been able to dry.
Yeah.
And if you're going to spray foam on that, then that goes right out the window. It can only dry out to the face, and if you paint it, then you've reduced the drying potential even more.
And imagine the mess of the foam oozing out through the gaps in this sheathing and claps. You can see it in the photography,
right.
like the daylight, right?
Yeah, right. You should have spray foam on the outside of your house, right?
You can do that if you really wanted to.
No,
Turn
I'm saying
it into a big igloo cooler.
It would work its way through the cracks.
Oh, yeah, totally. Yeah.
Well, in that case, I mean, you just turn it into like an installation art piece and make it look like something after the Stay Puft Marshmallow Man blew up.
Sounds horrible.
That's what your house looks like.
Was this fairly common to just go right to the siding like that?
Yeah, for a period. And this house has some like timber frame elements and some like stick frame elements, like many homes in this transitional period, right? So,
yeah, you timber frame and then just infill with dimensional, just for attachment of lath and that kind of thing.
So for those of you listening, the photographs we're looking at give me flashbacks and a case of anxiety. So all of our habitat houses look like us on the interior, and it's just like so impossibly disgusting pulling down plaster and lath in Pittsburgh, especially because it's behind every wall and ceiling is like an inch of coal soot from the industry and the heating systems that were in place when these homes were built. And it stays in there and accumulates forever, and it is so impossibly nasty.
Well, and these homes were not insulated when they were built, and the ones that I've worked in typically were insulated at some point later, usually in this, I don't know, 70s, 80s, something like that. And
with
the only way
fiberglass?
the only way to really get anything in there, they were using vermiculite.
Yes,
so
that's worse.
The first thing you do is you smash a bunch of holes in the bottom of the wall and just watch this stuff pour out.
Full of asbestos.
Yeah, and clean that up.
So those of you listening, vermiculite is a mineral, and if you like heat it in a kiln, it expands, and it's cheap, and it's a like insulation you can retrofit pretty easily because it pours like.
Is it a foam product?
No, it's
a mineral.
It's
right. You just
it's mica.
Mica,
a form of mica.
So the same stuff that you find in like potting soil is different.
Yeah.
And the only problem with it is that the deposits of it are also loaded with asbestos. So in many instances, or most instances, this stuff is contaminated with asbestos fibers, and you have to deal with it very carefully because it's easy to make those fibers airborne. But it doesn't look like he has this problem.
Hopefully he's still wearing a respirator, though. That looks like nasty stuff in there, huh?
Well, I just hope he's protecting his little child because, when you're making a mess like this in your house, you really got to be careful that they're not getting the lead chips and stuff in their mouth and just crawling around, because babies put their hands in their mouth and they pick up toys and then put those in their mouth. So, it's a risk.
For a project like that, Patrick, though, would you wear a respirator?
Oh, God, yeah.
Yeah, definitely. Yeah. God knows what's in there
right?
and that stuff.
Well, just the particulates are not good to breathe,
right.
It's not a good thing.
Well, I mean, now mica itself, I mean, even if you discount the asbestos portion.
You're talking vermiculite.
Vermiculite, yeah. Like mica, all micas, if I remember my geology classes correctly.
I always love when we have geology with Matt.
Are sheet silicates. So they have silica in them. And if you have silica dust, respirable silica dust, that will also scar your lungs. And you're going to end up with COPD or something.
I wonder if the vermiculite has that same quality because it's dusty. I've been around it.
Yeah.
Oh my God! So, do you guys remember Isaiah?
I don't
Thomas?
think so.
Isaiah lives up in northern Maine, and he's asked us a couple questions. He's an apprentice carpenter. He works for a remodeler, as I recall, up there. And the first thing we heard from him was regarding he wanted to make the attic space in his parents' home a bedroom space.
Oh, yeah. I remember that.
And so he sent us this photograph of someone in northern Maine whose rear window in their Ford Explorer is patched with zip tape. Which
That's
seems like
awesome.
the perfect material for that.
Right?
Yeah. Very sticky. You can do a lot with it.
It's cheaper than a window.
One thing you can't do with it,
Tell me.
wrap it around an entire foundation where you're trying to hold rigid foam onto it on a windy January day.
So you guys had this issue where you're trying to get foam to stick against the foundation wall so you can backfill and then it'll stay on their own. So the attempt was to
Put
wrap
all this
this
stuff
like a
up,
bungee.
yeah, put like maybe 5 or so Hilti pins into each piece and then wrap the entire thing with zip tape around this, I don't know, probably 2,700 square foot house.
Oh my God. When did you do that?
Exposed foundation.
Was that-
When I was working for a builder. This is like when I was in school, but I was
Okay.
on winter break,
Yeah.
and so I was, picking up some odd jobs, and
That being the oddest.
yeah,
So how-
it was
so
a
what
very
happened?
cold day. We came back the next morning, didn't find one piece of insulation.
It just blew
No
away.
idea where it went.
Oh,
I mean, probably like, I don't know, 60 sheets of 4
oh
by
my
8
God.
blue
They were like
insulation.
puffins
How
and
far could
marine
they blow?
wildlife choking on your styrofoam. Now I
Yeah.
want you to know.
This was like on an exposed hill on a what probably had been a farm back in the day. Actually, it
That's
definitely had been a
terrible.
farm because there was all kinds of old
Was this in
farm
upstate
equipment.
New York? Because there's
Yeah,
a
this
lot
was
of foam
This
blowing
was in
around
the
up there.
Western Catskills. And it
Someone
was
just set that on fire.
probably.
Yeah. Oh man. God, we had some good questions this time. I thank all of you for writing in, and I would remind you to please send me your mailing address when you send in a question or a comment, because it makes my life so much easier to send you a sticker, and I want to do that. The program is humming along. Do you guys have anything to add?
I don't, but I do appreciate the time and thought that our listeners put into their emails to us.
They're really smart.
They're really smart. They're very well written. They're
Yeah.
thoughtful.
The
And
questions
they
are,
help inform other people. And
the
I-
questions are good. We almost
The
never get a
responses
dumb
are
question.
terrible.
The responses need work for sure. Well, unfortunately, that's all the time we have today. Thanks to Matt and Kylie and Carrie for joining me, and thanks to all of you for listening. Remember to send your questions to fhbpodcast@taunton.com, and please like, comment, or review us however you're listening. It helps other folks find our podcast. I just got one other thing. So I told you guys about my new sunglasses before I went to the builder show. Unfortunately, they did not come in, but are
Whoa.
these freaking awesome
You
or
are a
what?
whole different person
Is that
right
them?
now.
Yeah.
Those
Oh my
are
God, Gaddafi.
sweet.
Where's your funny hat?
Did you get those in Vegas?
No, I bought these in
You should have
Newtown,
been wearing
Connecticut.
those in
I
Vegas.
wanted to be, but they were not ready in time. But I
see.
picked them up yesterday, and I couldn't wait for the sunshine, so I decided just to put them on now in the office.
Are they prescription?
Heck yeah. You guys would be baffled knowing my frugalness and what these cost.
Uh-huh.
I'm not going to tell you.
Gold mirrored lenses, though. For anybody who can't see,
Wow,
Patrick has sunglasses.
I did not see that coming.
With gold mirrored lenses.
Yeah, man, you got a whole other side to you.
Are these
I
awesome
like
or
it.
They
what?
are really fantastic. I only want a pair.
I came home yesterday, and Carol's just like, I can't stop looking at you. Thanks to all
that's
you
fun.
for listening, and happy building.
Oh my
Those
God.
things are fantastic.
So I've never seen glasses like that before.
I hadn't either.
I haven't
Where'd you
either
get-
on
where'd you get
anything other
them?
than a Middle East dictator.